this is the very common types of machine learning. I think you've already heard about these definitions, so I just touched the surface there. So supervised learning and unsupervised learning, some semi-supervised learning, reward-based, or commonly people just say reinforcement learning. So what's the difference between them? The first one, when you train the model, we give data with the desirable label. So say, when I gave them this data, I gave them as those are different classes. So just you put it like a circle or X, and the algorithm might find the division line. And that's the supervised learning. And unsupervised learning is the opposite. We don't give them the right answer, wrong answer, but just the data. Then they will just train themselves and find the best way they could define this task. And semi-supervised is kind of, both a mix of the both. So when you have large amount of data and you have some of them with the right tags, right label, then you can use them the text data for the supervised learning, but the rest for the unsupervised learning. That's kind of the concept. And the reward-based or the reinforcement learning, that's pretty new in this AI domain. And the very popular application is AlphaGo, I can say. We can touch this a little bit on the next slide. So I suppose our main interest is in the supervised learning at the moment, especially these classifications and regressions. I'll just briefly touch this again. I know you know this definition. So the classification is when you have data, and our goal is just to categorize the data into separate groups. So, for example, you have this data, and I'm not going to touch the KNL and the K-nearest neighbor algorithm here, but just this is an interesting illustration, so I brought that. So let's say you have this point, you want to predict what's the answer like. Would it be yes or no? So then I say, all right, give me the closest answer, the three of them. And I got yes, yes, no. So 2 yeses and 1 no. Then I say, all right, so I don't know what your answer will be like, but it looks like you will probably get yes, because major of your neighbor got yes. So what we want to get at the end of this algorithm is yes or no. That's the the classifications. And the regression is different. It's we are predicting a response. Normally it's a number we are talking. So the same example, but it's a number. So say, what percentage am I getting? Like, I don't know, but I wanna estimate it. So they give me the my neighbor's responses. So I got 82, 80, 76. So I don't know what your answer will be like, but it's likely 79.3% because that's the average out. Yeah, so that's the regression. I'll move on if there's no question so far. So interesting reinforcement learning. Yeah, we mentioned AlphaGo here. So why it's so special? Like most of machine learning we know is nearly the reinforcement learning. So why it's so popular? because I'll just read it out. We don't explicitly program all possible agent behavior, but create agents that can learn how to act optimally, right? So we don't give them how to play Go, but just let the agents play and then win or lose, and they find the best move, the best possibility on the next move. That's the reinforcement learning. So we can say what they're doing is decision making based on the probability they have. Of course, agents are interacting with their environment, but the same actions, I mean, like say move to this this location, doesn't always give you the same result, like how many winning chances. Depends on your current state. I think you got me there. So how does it work? That's the key, I think. So when the agents behave in a good way, like a winning way, then we reward. But if they behave like stupid or they're losing the points, then we punish them. It's a little bit cruel. So at the end, what we do is just maximize the long-term rewards and then find the best probability on the next move based on the current state. Yeah, that's it. It's quite a heavy topic, but interesting topic. So I'd love to do a little bit of work or do small projects if anyone is interested in this. Okay.
Yeah. So, just can you please go back? Yeah. Any idea? I mean, I know this AlphaGo. It's from DeepMind. DeepMind is acquired by Google, so it's part of, I guess, UK company. Then Google acquired DeepMind, and that's their AI project or AI product. I think they, I'm quite sure they use something called Monte Carlo tree search. So that's how they train their model. It's basically a graph, then how to traverse the graph, which path they have to take. That's how these agents are trained, by looking at how two Go players are playing Go game, and they assign those weights to their ages. And after, I guess, after a couple of months of training, they're smart enough to beat the best in the world.
Yeah. Yeah. Well, there's a lovely documentation as well, isn't it?
Yeah, it's yeah, the basic is, I guess it's all graph algorithms, Monte Carlo tree search techniques they have used. And I guess they have open sourced their APIs now. I've seen last year, I guess. Maybe you can do a search on that, or I can share you those links. I came across that they have open sourced their APIs.
Oh, that's interesting. Yeah, that's a good starting point, I think. Thanks a lot.